Hey everyone, so today we're going to talk about arcs and chords. We're starting on page 7 in your packet. First of all, a central angle is an angle whose vertex is in the center of the circle, and it's also congruent to the arc that the angle creates. And an arc is an unbroken part of a circle consisting of two endpoints and all the points on the circle in between them. So if I just draw this circle here, put a couple points on here, and that part of the circle is called arc AB. All right, so a minor arc is an arc whose endpoints are on or in the interior of a central angle. So right here, A to C would be your minor arc. A major arc is an arc whose endpoints are on the exterior of a central angle. So in this case, arc ADC. And you follow that path. So that would be a minor arc and a major arc. And we would just list this one as AC. If the endpoints of an arc lie on a diameter, such as E and G there, then the arc is a semicircle, or a half of a circle, and that's going to be equal to 180 degrees. Okay, so again, just remember that when you're looking for the length of an arc, it's the same as the angle that's there. So with this first one, we're looking for CDE. I'm just going to kind of highlight that. CDE. Well, I can see that this is 90. And since this side over here is 18, this is also 18 because they're vertical. So 90 and 18 gives us an arc measure of 108 degrees. And you measure an arc just like you would an angle with degrees. Okay, on the next one, I just want to point out that we do have a diameter here. So that 180 is going to come into play. So JKL, let's highlight that. JKL. Okay. Well, do you notice how this is also a diameter? So JKL is this region here. I can just take and subtract 180 and 40 to get that measure. All right, LJN. So L to J to N. That's a major arc. So it's basically all of the circle minus this part here. It's like Pac-Man. So the whole circle would be 360. So if I subtract out this section, which is 40 and 25, 360 minus 65 is going to give us an arc measure of 295. All right, one more like this. So we have 30, which means that this one's 30 over here. We have 105. I see a couple diameters there. Let's see what they're asking. So the first one, arc LMN. So LMN. Okay, well, first of all, I see that this is the diameter, which means that this whole part is 180. So if I want to find this part here, I could just add these two together, 135, and subtract from 180, and that would give me 45. So now if I want to find my arc, LMN, 45 and 35, or excuse me, 45 and 30, 75 degrees. All right, and then let's use a color that's going to show up here. Blue, I guess. Okay. So LNP now. LNP. So we're going all the way around here. Well, this is 180 degrees plus 45. It's That's all you got to do. 180 plus 45. Because you have this semicircle plus the 45 extra. So it's going to be 225 degrees. All right. So that's it for central angles. Let's turn to page 8 and talk about just one more thing today. So in a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord. So if you look at this diagram, CD is perpendicular to EF, so that means that these two parts are the same. And the converse is also true. If these two parts are the same, then they're perpendicular. So let's look at a couple examples with that. It says find QR to the nearest tenth. All right, well, there's going to be a couple steps here. First, I want to point out from P to S is a radius. Okay, and the radius would be 10 plus 10, 20. Well, you can draw a radius to any point on the outside from the center. 20, P to R, 20. Keep that in mind, okay? So if I'm looking for QR, what I'm going to do is I'm going to split it up into 2. I'm going to put an X there because I know whatever that is, this is going to be as well. I know that this part of my right triangle is 10. We're looking for this part. And the radius we just said was 20, no matter where you draw it from. So if we pull that right triangle out and take a look, anytime you're missing one side of a right triangle, you can use your Pythagorean theorem, where your radius is your hypotenuse. So x squared plus 10 squared equals 20 squared. Solve it. X squared plus 100 equals 400. Subtract that 100 over, so x squared equals 300. We'll take the square root. It does say to the nearest tenth, so when you do this in the calculator, I'm going to go just a couple spots beyond that, so it's 17.32. All right, so that's the measure of x. If you're looking for QR, we're just going to then multiply by 2. So in your calculator, just hit times 2. So QR is not the 17.3, it's going to be 34.6. All right, let's try another one. So on this one, you can see that this is perpendicular, which means this and this are the same. Your whole radius, I like to find that first, from the center to the outside would be 10, 6 and 4. So that means this is 10. And if I were to draw this, that would be 10. So again, you're dealing with a right triangle. You have the 6, you have the hypotenuse, and you're looking for one of the sides. Again, you're looking for the whole length of NP. So we'll just figure out half of it and then multiply by 2. So again, we're dealing with a right triangle. This is our C, so x squared plus 6 squared equals 10 squared. X squared plus 36 is 100. Subtract the 36. X squared equals 64. Oh, this one works out nice. So x equals 8. So this is 8 and this is 8. So if I'm looking for NP, it's going to be 16. Okay, the only other thing I wanted to point out, PT bisects angle RPS. So RPS is cut in half. That means this is the same as this, which means this and this are the same as well. Because remember, with a central angle, the arc that's across from them is the same. It's going to be the case for any segment that's in between it as well. So 6x equals 20 minus 4x. We'll solve it. Since we have to move the minus 4x over, it's going to become a plus. So 10x equals 20. Divide by 10. X equals 2. It wants us to find RT though. RT is 6 times x. So 6 times 2 is 12. Okay, so just to recap, central angle is the same as the arc that it intersects. If you have a half of a circle, it's 180. If the whole circle is 360, and just figure out what you're working with. If you're dealing with a radius being perpendicular to a chord, it cuts those into equal sections, and you can use Pythagorean theorem because if you draw a radius to any point, it's going to be the same. All right, so homework is page 9 and 10. All right, you will start to see a couple review questions in there. Just one hint on this one. This is half, so 32. Start with Pythagorean theorem to find your height. Then you can find the volume. All right, you're going to see more and more Regents review questions show up in the homework. All right, so again, 9 and 10 for homework, and we'll go over it tomorrow. Have a good day.